Welcome to the West of Scotland area group of MERG. My name's Chick Thompson, and today we're going to talk about USB and USB drivers. USB is Universal Serial Bus. It was brought in the 90s to replace all the clutter that used to hang out the back of computers. Parallel printers, SCSI interfaces, RS-232, scanners and printers and mouses and keyboards and video captures, and there used to be all manner of possible knobs and stuff, connectors all hanging out the back of your PC. And the idea was that if you get a single connector, you could rule them all, including DCC controllers, C-bus controllers and the like. Moving on, straight onto the hardware, everybody should recognise this. This is the standard so-called Type A connector. But everybody has seen one of these, and everybody has plugged one of these in. They go in 4 different ways, and it's always the 4th way that you choose that actually makes it fit. Don't know how that works for a thing that it looks like it can only go 2 ways, but it's always the 4th way that fits. You'll also notice that pin 1 and pin 4, the little strips of copper on those are designed to be a little bit longer than the strips of copper on 2 and 3, so that when you connect it, the supply is connected to the device a millisecond or 2 before the data is connected to the device. So the device is powered before the data connections kick in. And there's the socket that it plugs into. The standard socket is the one at the left, although they don't always have that nice metal escutcheon round about. The blue ones are for USB 3. The past 3 or 4 years, USB 3 has emerged, and it's got these blue tongues to the USB. So if you look at a USB socket and it's got a blue tongue to it, then it's a USB 3 socket. Now that means it is capable of going faster if the device that you plug into it is USB 3 compatible. But if it's not, if anything's just USB 2, then we all go back to the USB 2 standard and nothing's lost. Yellow tongues are what are called charge and sleep tongues. If your device has got a yellow tongue on it, then first of all, it's capable of delivering more current, typically up to about 2 amps for charging a phone or charging a tablet or stuff like that. And also the design states that something with a yellow tongue on it should stay powered when the device goes to sleep. So if you've got a laptop with a yellow tongue in the back, you can plug your phone in there to charge. And if you sleep the laptop by putting the lid down, the laptop goes to sleep, but that power socket doesn't. That USB socket stays alive to charge your phone or charge your tablet or whatever. So these are incremental changes to the standard that have come on there. If you look very, very closely at that USB 3 tongue, you'll notice that there are other little bits of copper there that are USB 3 specific. We'll get to them in a wee minute. It's very, very easy to hack. Those 4 wires, the 4 tongues, the 4 connectors on the tongue are not 0.1 of an inch apart. So the wires that come out the back of the socket and the back of the plug solder straight onto their board without any intermediate wires or connectors. You can just solder a USB plug or socket straight onto a piece of strip board. In fact, you can just use a piece of strip board. But the thing at the bottom there is just an ordinary bit of strip board that I use to plug into a USB socket. And there's the positive wire, the negative wire, and the 2 data wires. If you're going to do that, I suggest that you put a little fillet of solder along each of the bits of strip board to make it a better fit. I left that one open just to let you see that it was strip board that I was using. But usually I've used these, and what I do is I have a fillet of solder all the way along the 4 strips, so that it just plugs into the front of the PC, and I've got the USB connections coming out the side. So you don't even need to buy the plugs and sockets. Here's the type B, the original type B connector, 4 wires, 2 in the top, 2 in the bottom. And again, there's 4 ways to plug these into a printer. And the 4th one that you choose is always the one that's correct. The beauty about these things is they don't break so readily. The flat type A tongues, people break those. I have spent a lot of years fixing USB connections on computers and stuff by having to replace the USB-A connector, unsoldering it and resoldering it, because people break them. And when they break them, they stop the motherboard from working. But USB-B end like this is much more robust. It was a bit big though. And so the Mini was brought in. And most people don't know that there are 2 Mini ends, a Mini A and a Mini B. Everybody's used to the Mini B end, but there is also a Mini A end for the PC. If you've got a tiny PC or a very, very thin laptop, it might have a Mini A socket on it, but they're very, very rare. But I'll mention them in the way passing because I'm trying to cover all the ground. And then there's Micro. Micro is even better, even smaller than the Minis. And Micro grew out of the European Union. Early in 2000s, there was a European Union directive that said that all mobile phones should have a standard connector on them. Up until then, there was mobile phones with all sorts of weird and wonderful 4-way, 6-way, 20-way connectors on them. And the EU said, if you're going to sell your phone in Europe, it has to have a standard small connector that will charge off 5 volts. The idea being that they wanted to eliminate the plethora of chargers to try and save electrical waste because they were trying to save the planet. But as a result, all the mobile phone manufacturers moved to USB micros and they've become absolutely ubiquitous. Practically everything now has got USB micros on them, and that's what they look like. And then there's variations on the theme. I've already mentioned the USB 3 type A sockets there that have got the little extra bits of copper between the tongues to accommodate super speed. And there's also a micro B that's a wide flat version of the B end for a micro, the micro connector. I've got them on a Elite Motion HID, a human interface device, and I've also got them on a very special external hard drive. What isn't immediately apparent with that micro B with the extension on it is that half of it is still an ordinary micro B connector. So if you've got one of these, but you don't have the cable, then all you need is the standard micro B cable, and it'll plug into half of that, and the thing will still work. As I was saying, these things are easy to hack. This is from eBay, £2.59, buys you 11 connectors, all connected to each other. And supposing you just chop the ones you don't want off and throw them away, these connectors are very, very cheap. Now, as I was saying, easy to hack. There's a collection of sockets, and using those little intermediate 6-pin things, you can connect anything there to anything else, because all the pins are the same pins in the same order. So if you want to connect anything to anything else, and also with those you can connect anything to a breadboard. If you're not wanting to plug a USB input or output or micro or mini or whatever to a breadboard, you can plug them in with those. So there's lots and lots of hacking possible with USB. The initial USB standard from 30 years ago now, almost, was for 12 megabits per second, which is about just over 1 megabyte per second. It was superseded very short order by USB 2, which is 480 megabits, which is about 60, isn't it, megabytes per second. And that's the standard that everybody's using. That's the one that my dodgy webcam operates on, and practically all USB operates on. The blue USB 3 that's now coming out should do 5-point-something gigabytes, and USB 3.1 proposed, just starting to appear, 10 gigabytes. They're all back compatible. That means that if you've got a USB 1 device and you plug it into a USB 3.1 socket on your PC, it should still work. There should be no situation where you're left with a peripheral, a device you can't use. USB-C get mentioned. Because of people plugging in tongues upside down and breaking the sockets, it was decided to bring in a socket that you couldn't plug in upside down. And that's what USB-C is. It's about the size of a USB micro, but there's no polarity to it. There's no plugging it in upside down, which looks like a great idea. However, there's the socket. Right, you count how many copper connections are on there. Right, there's I think 24 on that one. Everything has to be duplicated on both sides of the socket, which means that the socket has a couple of dozen tiny fine wires on it, which makes it very, very fragile. Plugs in either way up. It's a very small part. It's got a very high density footprint, so it's fragile. Not everybody routes all the connections to that connector. If you think about it, getting the V plus to all the V pluses on there, and then the ground to all the grounds on there, and then the D pluses, is a routing nightmare for the guy designing the PCB. So what they sometimes do is just route half of it and hope that you plug the cable in the right road. So you get to a situation where my printer doesn't work. Okay, have you plugged it in? Aye. Have you tried plugging the cable in the other way up? But the cable's in. And you take it out, turn the cable, plug it in the other way, and it works. Or even worse, you get cables that are partially routed, whereby the cable works in one direction but doesn't work in the other direction. USB-C can be it's not a nightmare, but it's something that you have to be aware of. If you're encountering USB-C, then a lot of the logic that you already apply no longer applies. Cables might only work in one direction, they might not work in both directions. The thing, even though it plugs in both directions, one of them might work, the other one might not. So when you've got a USB-C device and a USB-C computer, it might be 6 or 7 goes to get them to talk to each other with the same cable, right? So it's not all improvement, let's put it that way. And there's PD. PD is something called power delivery, which I'm about to rant about because I reserve the right to rant about anything, because Davey said I can. Power, before I can talk about power delivery, I've got to talk about powering USB devices. A low power device, less than half an amp, can be bus powered. The webcam that I was using when I started this nonsense today takes about 500 milliamps, and when it gets hot, it takes about 600 milliamps. And when it takes about 600 milliamps, it cuts out. And guess what happened today? It cut out because of the power requirement. If you've got a high power device like a printer or a scanner, you don't need to power it off the USB. It can use an internal supply, a mains supply, or a battery supply, or whatever. Now the rule is, the specification for USB says that the PC, the master device, should protect against overcurrent, so that if something draws too much current, the PC should pop up a warning and say, you've had an overcurrent event on one of your USB ports, please remove it, or please reset it, or that device has been switched off. But that's a should. Not everybody does it, right? And for that reason, you have to be a wee bit careful. So one of the good reasons for using a hub, and we'll talk about hubs in just a moment. Right, that's how to power a USB device. There's the USB, it gives you 5 volts. There's the battery. Let's say the battery gives you 6 volts. And there's the mains, and let's say the mains gives you 6.5 volts. If only one of these is here, if one of them is present and the other two aren't present, then current will flow through that diode to the circuit, and the other two diodes will stop current going back to the other supplies, which makes sense. But also, if there's more than one here, let's say you've got it plugged into the USB and you've got the mains on, then what will happen is that the supply that's providing the highest voltage, its diode will be forward biased. The supply that's got the lesser voltage, its diode will be reverse biased, and so it won't be passing current. As a result, the circuit will take its current from whichever supply has got the highest voltage. So 5 volts for USB, 6 volts for the battery, 6.5, 7, 9 volts for the mains, and that way, whatever one's in, preferentially, will power the circuit. And you don't need a selector switch to say, I wanted to put it in that mode or that mode, and forget to leave it in battery and your battery go flat or any of that stuff. You can do it automatically just with a couple of cheap diodes. It is possible, and I know that there's one or two people here, because I've spoken to them about it, to get a cable that is power only. It's got the 2 wires for the 5 volts and the ground. It doesn't have any data cables connected through it. Now, these are there to charge devices, to charge phones and so on. And very often what you do is you get them connected to a charger, whoops-a-daisy, connected to a charger for plugging into your phone, and then you realise, oh, look at that, you pull that out as a USB. But the thing is to not pull it out, just leave it attached to the charger. If it came on a charger, leave it attached to the charger, because it might be power only. And if it goes into your bag of USB cables, then it's going to let you down one of these days when you're looking for a cable, and it turns out that the cable you just picked up doesn't connect the data through. You want to monitor the power? I've got one of these things. It's simply inline. USB plugs in there, that plugs into your PC, and it tells you what voltage and current you're drawing, and you can look at that. I bought that, and it was so successful that my wife took it off me, and she now uses it for working out how charged her tablet is. It's in the kitchen, and I don't get near it, I don't get to touch it anymore, so I'm going to have to buy another one. The other one that I'm going to buy costs half as much, but it will also do PD testing. I keep talking about PD, power delivery, because I hate power delivery, and I'm about to explain why. Before PD, there was this system whereby there were resistors built into the charger between the supply voltage and one of the data lines, or both of the data lines. And that way, the PC knew if you had an Apple charger or not, or you had a Samsung charger, or a Sony charger, or if you just had a general purpose somebody else's charger. And if it was an Apple charger, it knew it could take 3 amps, for example. But if it was just a standard anybody's charger, it could only take 500 milliamps, because it might be a PC. And if it takes more than 500 milliamps in the PC, it's going to destroy the PC. So if I've got an Apple charger, then I can run Apple charge currents. But how do I know I'm an Apple charger? Well, what we do is we put a couple of resistors between the supplies and the D plus, the supplies and the D minus. And as long as those voltages are there, you can tell what type of Apple charger it is and what you can and can't do with it. And these were becoming quite ubiquitous. It was getting to the stage where you had to use the charger that was supplied by Sony or Apple or Samsung to get the best charge for your device. But that was overtaken by this thing, power delivery. Power delivery is a system sometimes called quick charge, or compatible with a system called quick charge, whereby the device and the charger negotiate with each other via a little data exchange back and forth over the data lines. What voltage can you supply? What voltage do you want? What current can you supply? What current do you want? And so on. The PD maximum can be 5 amps and it can be 20 volts. But 20 volts can destroy a lot of things, and 5 amps can destroy a lot of things. So you have to get this right. Right? I'm not a great fan of PD because mistakes happen, errors happen, and devices are being destroyed for really not good reasons. There's the PD standard. If it's a small device, like a set of headphones or a pen drive or whatever, then it'll supply 3 amps and 5 volts. For a smartphone, a camera, a drone, 3 amps at 9 volts. Tablets and small laptops, 15 volts. And again, for a big tablet, a large laptop, a computer display, then PD will deliver 100 watts. But again, you have to buy a cable that's as thick as your thumb for that, because 5 amps at 20 volts is starting to be quite a bit of an issue in terms of delivering the power over the cable. Now, not that there's been any issues with this, and it's not been in the text, in the news or any of that good stuff. This is 5 years ago. USB laptops are playing Russian roulette. You get either end of the cable dirty, it overheats, it draws too much current, you start a fire if you're lucky, or you destroy your laptop if you're not so lucky. And then there's USB on the go, USB OTG. The original USB specification was for some device like a computer supplying a device like a printer or a scanner or whatever. Data can flow in either direction. And then it was realised that, wait a minute, if I've got a phone, a mobile phone, that connects to my PC as a device so that I can use it as a mass storage device or for transferring pictures on and off. But when I'm away from the PC, what's to stop me using the mobile phone? It's got as much power as my PC, computing power. So what's to stop me using that computing power and that USB connector with something else? Somebody with limited mobility, for example, wants to use a tablet and I want to give them a mouse. Then I'd like to be able to plug a mouse into a tablet. But you don't get mouse and mice with the right socket on it. So there's this on-the-go standard whereby I can connect devices to micro USBs. Let me just click forward one here. You have to get this magic cable, costs you a £5. The micro USB plugs into the phone or the tablet, and then the other end you can plug a pen drive or an external hard drive or a keyboard. If you've got a tablet and you'd like to use a keyboard, for example, and you'd like to use a mouse, you can do that. Not everything supports USB on the go. And there's an issue to do with power. If you use a device like a keyboard that draws a couple of 100 milliamps and you plug it into your mobile phone will be flat in half an hour. So you have to supply power. So generally what you do is you put this cable in, but you connect a power tub to it. And once you've got a power tub, then that'll power all your devices, your external drives and your mouses and your keyboards and so on that you want to plug into your phone or your tablet. But it is possible. Which brings me to hubs. There's about 4 different chips that they use for making hubs. And for some reason, best known to the guys that design this stuff, the 4 chips are all 1 input to 4 outputs, which means when you're getting a hub, you're going to get 4 outputs, or they'll take one of those outputs and connect that to the input and another 4 outputs, in which case you get those 4 plus the 3 that are left, which is 7, or 10, or 13. So it's always these weird numbers of outputs that you get. And what's actually happening in a 7-port hub like that, you've got 2 of these chips. So three of the connections to that hub go via one hub to your PC. But some of them go through 2 hubs before they get back to your PC. When they go in the back of your PC, they meet another hub. The idea of USB is what they call a star topology, whereby there's one connection that gets starred to 4, and each of those can get starred to another 4 and another 4 and another 4. It can go up to 128, but they're not all used. It's a very good idea to have a powered USB hub, because that way, if you have an accident, if you short something out, particularly if you're tinkering with electronics, if you're going to short something out and blow something up, it's cheaper to blow that hub up for a tenner and put it in the bin and buy another one than it is to blow the motherboard and buy another one of those, because while the motherboard's blown up, you're coupled off. So for that reason, a powered USB hub is always a good idea. The chips that they use inside the hubs also come in 2 flavors, STT and NTT. That there just says what I've just said. By God, this fella's good. He sometimes knows what he's talking about. STT hub is a single transaction translator. What happens is the transaction between my printer and my PC to go through the hub gets translated as if it's coming from that end point of the transaction to that end point. So some of these chips can have multiple translations going on at the same time. They can have multiple conversations going on at the same time. Some can only have one going on at a time. So for example, I've got a PC and I have stuff coming off the pen drive and going out to the printer. If it's an NTT hub, then the stuff coming in from the pen drive can be coming in from the pen drive at the same time that it's going out to the printer. Both transactions can be happening at the same time. Whereas if it's an STT hub, then it's got to come in from the pen drive transaction finishes, it then goes back out to the printer, and once the printer's finished taking its data, that transaction stops, and we go back to the pen drive and we take the next mouthful, and that's going to be a slower process than if it's an NTT hub. So when you're buying a hub, look at the detail and see if it's an NTT hub, because that's probably going to be a quicker, better hub than an STT one. And that's the hardware. I don't want to talk any more about the hardware. The communication in USB takes place in what's called transactions. A transaction happens between an endpoint and an endpoint. The endpoint is one in the device, one in the PC, typically. The transactions are translated on the way between by hubs, and you generally get quite a few hubs. The device itself has to provide the endpoint details, and the PC has to provide endpoint details. The PC endpoint details are very often referred to as the USB device driver. You've got a such and such machine, oh grand, you're going to have to get a driver for that. You're going to have to download drivers for their website. And this talk of drivers actually covers a number of things. It covers an information file, it covers a number of executable files that are all lumped into the term, the device driver. There's a thing called the vendor ID, which I'm about to talk about, the product ID, the product class, the capability specification, and little bits of code to handle the various interactions that are associated with the device. Obviously, every device has got its own quirks, and the little bits of code are quirk specific to do with the device. I will explain this stuff in a wee bit further detail as we move forward. First thing that happens when you plug a device in is a thing called USB negotiation. I've got something here to negotiate. When you plug it in, the USB subsystem will identify what device it is. Has this device been connected before? What class is it? What speed is it? And it'll make a noise. And the noise will be like this. Come on. Yep. And that noise there is when you disconnect. And there's a flat noise in between if it didn't recognize it. Very often it'll say, well, that's a valid USB device, but I don't know anything about it. I can't find a driver. I don't understand it. It didn't start properly. It didn't do its part of the negotiation process, in which case it'll give you this bloop, which means the negotiation has failed. Right? And that negotiation's happening when you hear those sounds, and that's what those sounds mean. The device manager is your friend when you're using USB devices. To get to the device manager, we simply press the Windows Start button down at the bottom and type DEV. And by the time you've done that, device manager will be on the options and you can select it. It shows every device that this computer is aware of, all sorted out by sections. The thing is that when you go and look at the bottom, there's a thing there called Universal Serial Bus or USB controllers. And mostly, those are just the hubs. If you actually plug a USB device in, it'll go to its place as the device in the device manager's tree. So if I plug in a device that's a COM port, it'll go to the COM ports. If I plug in something that's a network adapter, it'll show up in among the network adapters. HID, human interface devices, are keyboards and mouses and all that good stuff. And that's where the USB keyboards and mouses and stuff like that show up. So that the device won't necessarily show up down here where you think it would. What it will do is it will show up down here if the PC doesn't understand it. And if it doesn't understand it, it will show up with a little yellow triangle on the image. See how everything here has got a little icon next to it? If your PC doesn't understand something that it's connected to, then there's a little yellow triangle appears on the icon for that device, which usually means it hasn't got a driver. Every time you plug in a USB device, that device manager thing disappears down to nothing and reappears or refreshes itself, and the new device is in there. So you can actually watch, if this device is working, I'll open the device manager, and if I plug the device in, apart from hearing the sound, that should go tring, tring, and it should refresh. And if it doesn't refresh, and I don't hear the sound, it never recognised the USB device. And when I pull it out, similarly, it goes tring, tring, and that refreshes, and that lets me know that that USB device has been removed. Also, I can, for example, go to the COM ports. I've got a device, I've got an Arduino here, and this Arduino, I've got no idea what port it's on. So what I do is I go to the COM ports and look, and I see I've got COM port 1, COM port 2, COM port 3, and COM port 5. I plug in the Arduino, I've now got a COM port 7. That Arduino must have been COM port 7, so I know how to set the Arduino up. Or I set the Arduino up and look at all the COM ports, pull the Arduino out and see which one disappears. And that tells me that Arduino must have been the COM port that disappeared. So you can use this as a debugging tool. And if you're playing about with USB, then this is where you do most of your debugging. Expect some surprises. Very often, the device will not go where you expect it to go. Arduinos and little electronics boards, you've got a little board from ERG and it says CAN USB on it, and you think that's going to be a USB controller, or it's going to be and you plug it in and it's a human interface device. Why the hell is it a human interface device? Because that's the way the person that wrote the code decided to do it. I'll explain classes in a wee minute. If I right mouse on some of these, if I go to a COM port and right mouse, there's a wealth of information there. Every USB device has got a vendor ID and a product ID. The vendor ID says who made it, Microsoft, Dell, Hewlett Packard, Apple, whomsoever. And the PID identifies the product. This is a Logitech steel mouse. This is a Logitech TrackMan. This is a Logitech scanner. They've all got the same vendor ID because they're all Logitech, but they've all got different product IDs because they're all different products. In order to get a vendor ID, you have to pay $3,500 for 2 years. So every second year it costs you $3,500 to get a vendor ID. Once you've got a vendor ID, you can issue as many PIDs as you like. The PIDs are a 4 hex digit number, so you're allowed up to 65,536 of them, if that's what you want to do. Microchip, Atmel, FTDI, these are people that make USB connection equipment, things that you plug into USB sockets. And so they're quite happy for you to use their VID. If you plug something in that has got a microchip chip in it, then you'll get to use the microchip VID. If you then develop it and decide to sell 1 million of them, you've got to buy your own VID while you're selling it. But while you're developing it, or if you're only doing small runs and it's only for development purposes, then you can use microchips. So there's microchips there, 04D8. If you look at the JAL bootloader, that's 04D8. But then what's inside? What does JAL run on? It runs on microchips, right? Look at the merged CAN USB, 04D8. And the SPROG, I've got a SPROG and it's 04D8. So guess what's in? I've never opened the SPROG, but I know what's inside it. There's a PIC chip in there, right? And they've all got different PIDs because the guys have all given them different PIDs. If you've got drivers for microchip, for prolific, and for FTDI, you're 3/4 of the way to having drivers for everything, because an awful lot of kit uses those. And you can also use the VID and the PID to hack, to get something to work. Now this might sound appropriate, but it might not. I've got 2 webcams and one of them fails on my PC, but the other one works fine. So what I do is I plug in the webcam that doesn't work and I use the device manager. Go to the device manager, go to the dodgy device, right mouse it, and I can get the VID and PID from the details there. I then go to webcam B's driver and change the VID and the PID on it to make it think it's got the VID and PID that are on the other device. So that when I plug in the dodgy device, it loads the driver for the good device. We know the driver for the good device works. And 4 times out of 5, that'll make a device that doesn't work. I've used this a dozen times. I've advised it to 1 or 2 people that are currently on here. If you've got a dodgy webcam, you've got a webcam that works in Windows 7, but there's no Windows 10 driver for it. And what you do is you get a Windows 10 driver and just change the numbers to make it use the Windows 7 hardware, and it'll work fine for you. The inf file is a simple text file. It contains a list of the VID, the PID, what files it uses, what class of device it is, what it says, and you know in the device manager where it says Merg WASAG device or microchip device or whatever, all that stuff lives in the inf file. And whenever you plug a device in and load its driver, the inf information gets copied from wherever you get it from, either from the internet, or if you download it, or you put it on from a floppy disk or a CD, and it gets copied into C drive /Windows/inf. And you can go in there and bugger about with these, they're just text files. And what inf file you're using is in the device manager again. If you go to the device manager, find the device, right mouse it, and among the details there, you will find what inf file this thing needs. And therefore you can go to the inf file and you can find out all the bits of detail about what this device uses and where the code is and who wrote it, and all the stuff that you need is in there. There are 3 classes of USB device. The first one is called HID, or Human Interface Devices. Keyboards, mouses, small bits of gear. They irregularly send and receive small packets of data. A keyboard only sends a byte every few seconds. A mouse sends a couple of bytes a second, but no more than that. A DCC controller, a few bytes occasionally. Right? A CDC device, a COM port, has typically got medium data. You've got 1100 bytes per second, you've got 1000 bytes per second going and coming. That's getting up into there, and it's a slightly different device, so it needs a slightly different driver at each end. And then there's mass storage classes for pen drives, external hard drives, for getting lots of information from a hard drive, for example, or a network connection into a PC. And that's going to use all sorts of clever interrupts and low latency stuff, so it's going to be a different driver. But then since USB was developed, there's another standard called libUSB, which is people that have written this standard, which will deal basically with anything. And the deal with libUSB is that if you can't get one of the other drivers to work, the libUSB driver will work. So that's one that you should know about as well. And again, we'll meet it as we move on. Most devices are simple devices. You get 2 endpoints, one in the PC, one in the device. It is possible, though, to have a compound device. I've got a Dymo label printer, and it just plugs into a standard old-fashioned USB 2 cable. It doesn't need power. It just takes its power from the PC and prints labels. But when you plug it in, you get 2 devices. You get a printer for printing labels, and you get a tiny wee drive. I think it's about 10 megabytes of USB hard disk. And that USB hard disk contains the drivers and the program for the printer. So no matter where I take this printer and plug it in, I don't need to worry about downloading the drivers or carrying a disk with the drivers on it or carrying a program to print this, you know, oh, wait a minute, this is an Apple device. I want to plug it into an Apple device. I've got the program to run Dymo labels on an Apple. None of that matters because it's all on the drive that's on the printer. Right? So that's a very occasionally possible device. And sometimes if you find a device and you find it doesn't appear to have any drivers and there's no mention of drivers, what will happen is you'll plug it in and suddenly you'll have an F drive. My soldering iron, remember the wee TS100 soldering iron that you sometimes see me using at the 65 Club? When you plug it in, it has got its own little drive on board. And the idea with that is, if you save something to that drive, then that immediately gets uploaded as firmware onto the soldering iron. And you upgrade the soldering iron's firmware by saving things to this little drive that's built in to the device. So that's another compound device. As I said a minute ago, if you have an FTDI driver, a prolific driver, CH340, FTDI is a lovely wee company that started in Glasgow, spun off from University of Strathclyde. Some guys in, I think it was, don't know if it was the electronics department or the computing department, they're both the same school at Strathclyde. And a wee company span off to make chips. They don't have a foundry, they don't actually, import silicon and do all that stuff. What they do is they design the chips and then they send them out for manufacture. The first chip was USB at one side, RS232 at the other. And now they do USB to binary, USB to RS485, USB to anything. And there's lots and lots of these FTDI chips, and they're used universally. They're not the cheapest chips in the world, but they are dead reliable. They never ever miss. Prolific are a Taiwanese clone that does very, very similar things, but they're much cheaper. And the CH340 is a Chinese clone of the Taiwanese clone of the FTDI chip that does the same thing. None of their drivers will speak to each other, and so you have to have drivers for all three of them. Microchip, their devices go into an awful lot of gear as well. There's two types of FTDI driver, by the way, and what's called the VCP driver, and then the DTT2, DTT3, DTT4 drivers. You need one of each of those, but if you download each of those, download the Prolific driver and download the CH340 driver and the microchip driver, you will be able to drive practically anything. And that's why that slide is there. If you go to slide 43 in this presentation, there's a list of drivers that you need to go and download. VID is a guy in Ireland who wrote this lovely little program that's part of the USB effort. Remember the libUSB effort? libUSB is a universal driver that will drive any device that you can't find a driver for. And to do that, you need this VID program, which you get there. I'll flash up VID a wee bit further down through the chat. So, just before we finish, I'm going to talk about 3 or 4 specific USB issues. These are the things that come up that people have trouble with USB that I get asked to fix fairly regularly. My Arduino used to upload, and now my Arduino doesn't upload. What's happening? First of all, if you unplug an Arduino and plug it into a different USB socket, it might get a different COM port. And so it used to be COM3, it's now COM4. Or if you unplug it while it was doing something, let's say you had the serial monitor open. Right, I've got my Arduino's doing whatever it is it's doing Arduino things, and I've got the serial port open to show me what's happening, and I unplug the Arduino. That serial port was in the middle of doing something, it's left open. Right, so in order to fix that, what I do is I plug the Arduino back in, I go back to the device manager to make sure I've got the right port number. Then I go back to Arduino and make sure it's in the port number that I think it's in. And then if I do that and it's still not working, then what I do is inside the device manager, I can disable that COM port. And as soon as I disable it, the Arduino stops working, but I then can go straight back in and re-enable the COM port. And when I re-enable the COM port, it will renegotiate, it will set everything up fresh, and my Arduino should be back to where it was before when I first plugged it in. And at that point, we're away to the races. And if at that point it does still fail, then there might be a latch-up issue. That sometimes happens. And the best solution there is to reboot the PC. But you shouldn't really need to reboot the PC. Usually go to the device manager and disabling and re-enabling the driver, which uninstalls and reinstalls the driver, will reset your your Arduino, and away you go. I've just plugged my Arduino in there. I've plugged my whatever it is in. It's in COM47. Why have I got COM4? I've got COM1, COM2, and COM47. What the hell's going on there? It turns out that every time I plug in a CDC device, I get a new COM port. And it's always the next COM port up. If it sees a COM5, it'll put in a COM6. Doesn't matter if there's no COM4 or no COM3. Sees a COM5, well, this is going to COM6. And you end up, if you're plugging in a lot of different Arduinos and a lot of different CDC devices, then you end up COM23, COM27, COM40. Now, what COM ports are available are down to the guy that wrote the software. If I'm writing a program, I tell it which COM port to pick up. There's a couple of ways I can do that. The easy way is just say, oh, I'll give them any COM port up to COM9, COM0 or COM1 up to COM9. Right? And that's enough. That's enough COM ports for any bugger. Nobody's got 10 COM ports from their PC. On the other hand, I can actually say, enumerate the COM ports, go into the Windows operating system and work out what COM ports are there and make those appear in a list. And that's a wee bit more complicated. So some programs just say, okay, you're only allowed COM ports up to COM6, or you're allowed COM ports up to COM9. Others will give you all the possible COM ports they can see. But really, it's a good idea every so often to clear out all these COM ports that don't exist on your PC. So, back to Device Manager. It always comes back to Device Manager. At the top of Device Manager, you go to View, and there's an option there to show the hidden devices. And if you show hidden devices, lo and behold, there's all those old COM ports that you never use anymore turn up. And I can simply click on each one of them, right mouse, uninstall it. Click on the next one, right mouse, uninstall it. Click on the next one, right mouse, uninstall it. And away I go until I get rid of them all. And if I get down to just having COM1, then the next thing I plug in will be COM2. And we start again, going back up through the list. And I'll do this every couple of months to get rid of all the snash. You don't have to worry about deleting too many of these. If you delete a driver, if you delete COM11, you're not removing the driver. You're just telling it, I don't have that device anymore. If you plug something in that needs that driver, you've still got the inf file in C drive Windows/inf, and it'll find it and it'll immediately reinstall it. So you don't have to worry about, oh, I don't want to delete that Leonardo bootloader thing because I sometimes use that Leonardo boot. I can delete COM8 there because I know that I can still get back to that. If all I need to get back to that is to plug the hardware in again. So I don't have to worry about it. I can just right mouse, uninstall all afternoon till I get rid of all of these things. What USB devices have I got plugged in? I'm sure I had a USB device plugged in here and I've got a driver for it. I would like to know what USB devices I've got plugged in. There's another interesting URL, and this is slide 48 if you're taking notes. NurseSoft utilities is a set of about 150 little utilities that are brilliant. If you're hacking PCs, I can't praise the NurseSoft utilities high enough. I'm only showing you this one today. I could do a whole year of these talks about the NurseSoft utilities. There's hundreds of them and they're brilliant. Here's the USB devices view one. You run it and up comes this. The devices that are green, see the green stripes? Those are the devices that are currently plugged into my computer. The rest are devices that this computer's aware of. They've been plugged in, they've been unplugged, they're not here, they were in here once, somebody plugged it in when I wasn't here. There's the vendor ID, there's the product ID, there's when it was plugged in, there's the type of device it is, there's the description of it. every little detail about every USB device is available via that little utility. That little utility doesn't install on your PC. You're not going to get a bug, you're not going to get a snottery nose, a virus off of that, because it's just an executable. There's no drivers loaded with it, there's no DLLs loaded, there's no danger or anything. It's just a simple exe file, and it comes with a CHM file, which is a compiled hypertext module, which is the help file, and it's basically a web page full of help that you can look at for it. And there's, as I say, hundreds of those in the NurseSoft page, but this one in particular is really, really groovy if USB is what you're talking about. And today, USB is what I'm talking about. I've just tried to install this device. It's a Hornby controller. I've had it for the last 5 years. When I bought it, it was Windows 7. Now I try to plug it in, and it says, you can't plug this device in because it's not got a security signature. As of Windows 10, all devices that you plug into your PC need to have a security signature. Microsoft provide them, but they don't provide them. They'll provide them anything that's new. They'll provide them the old things as the demand appears, but not everything, particularly specialist stuff. And model railway stuff is quite specialist. And so you're likely to get a situation where you find something that you don't have a signature for. Now, you can self-certify, which means you declare yourself as a certificate owner and start making your own certificates and applying them to your PC. And I ain't about to go through that because life is short enough and brutal enough as it is without showing you how to do that. It's hard work. It's much easier to simply say, right, for the next time I switch this machine on, I want to switch the signature checking off. So I'll switch the machine on once with no signature checking. I'll install this device. And then the next time I switch the machine back on, signature checking is back on. But by that time, this device is installed and I'm away with it. I don't have to worry about that anymore. So in order to do that, I need to go to the advanced boot options. And nobody's heard of the advanced boot options because it's a secret. If you hold the shift key down when you're pressing restart in Windows 10, you get advanced boot options. I'm going to walk through this one because it's important. Go to the restart option, but hold the shift key down while you're restarting the machine. And you get this. Choose an option. Either go on and can exit and go to Windows 10, turn off the PC, which is what you wanted to do, or troubleshoot. Let's have a look at some of the advanced options. So I can either reset this PC and reinstall Windows, which is a bit drastic, or I can go to the advanced options. The advanced options includes recovering the system, doing a startup repair. If I get the new build of Windows and I don't like it, I want to go back to the previous build of Windows, I can do that here. But I can go to the startup settings. And once I've pressed that option, it will say, right, I'm now going to restart your machine, but when I restart it, you ain't going to restart normally. You're going to restart into this special menu. So that's what I'm going to do. And when I restart it, up comes this. You have to pick a number key or a function key. Number 7 is the one that we want. And number 7 says, I don't want to enforce driver signatures anymore. And it's only for this one restart. Yep, there's other options there. I'll leave you to explore those, or I'll maybe talk. See, the more of these I do, the more I realise there's other things there for me to do. I could be doing these for the rest of my natural life if I cover all these options. Anyway, you pick 7, and away we go. Pick 7, it restarts, but it restarts without driver signature, and when you plug it in, the thing loads, it loads the driver, and away you go. It doesn't complain about you're not getting loading this because of for lack of a signature. So for that reason, once you've been through that, you get the driver loaded, you get your device working, and when you next reboot, everything's back to the way it was at the start of the day. So you don't have to worry about that anymore. But that wee walkthrough takes you through the options. If I want to remove drivers, then a right mouse, device manager, yet again, locate the device. And once I've located the device, I'll go back into the details to find its information file. What inf name is it? So for example, I've got a device, I've got some waffle sprocket that I've bought, and I've been using it for years, and it's using an old device driver for Windows 7, and I want to, there's now a Windows 10 driver for it, so I want to install the Windows 10 driver. I want to install the new driver. Uninstalling a device driver is a wee bit, there's no mention of how to do that. You can uninstall a program in Windows, but there's no mention about how to uninstall a driver. So this is how you do it. You open the device manager and find the device. Once you find the device, you right mouse, go to properties, go to details, and find the name of the inf file. You go to C drive Windows /inf. If you notice that everything in this talk, everything in the software side is either device manager or C drive /Windows /inf. Yep. I delete the relevant inf file, and that's that driver deleted. And if that driver runs 3 different things and I've accidentally deleted them, then what will happen is I'll get prompted to reinstall it. And because it's been in there once, it'll reinstall again, so I don't have to worry about it. Zadig, I mentioned this before. This is the Irish fella. And this is another wee program that you should have in your PC. If your PC doesn't have a driver for something, then this here lets you, there you are, a smart card with startup contacts on it. I'll bet you nobody here's got one of them, and I'll bet you I'm the only one that's ever had to install a driver for it. And in order to install a driver for it, I couldn't find one. So what I had to do was bring up Zadig, and it gives me versions of drivers that will fit it, and I can pick the driver. I can either put a new driver in or replace it. And if I'd like to change the VID and the PID for whatever reason, I can do that too. So this is a technical driver hacker for USB. You can replace existing drivers. You can make driver A working with driver B. You can put drivers that don't exist into place, all with this wee program. It is a brilliant little thing, and it costs $0, my favourite price. Lastly, thank God they cried as one. Lastly, COM2COM. A lot of people are using a lot of devices that use COM ports. As I say, you end up with COM47 when you're using USB devices. Now this is technically nothing to do with USB, but a lot of devices expect to see a COM port, and very often nowadays you have devices that expect to see COM ports and expect to connect to other devices that expect to see COM ports, and you've now got them all on the one PC. Amateur radio, people tend to use these a lot. You've got a weather satellite decoder that's expecting an input for a communications receiver. But nowadays you don't have a communications receiver, you've got an SDR receiver that's on your PC as well. And so you need to connect the COM port that doesn't exist on that communications receiver to the COM port that doesn't exist on that weather program. So this little thing, COM makes 2 COM ports in the USB drivers that don't exist, but they're connected to each other by a virtual null modem cable. So you can send data out of one program into another program as if there was a cable coming out the back of your PC, going around your neck and back into the other COM port in the back of your PC. If you're using, like I say, radio, amateur radio stuff, CNC people very often have a program that's generating G-code and a program that's interpreting G-code, that's drawing their G-code to let them see what the part's going to look like. Both expect a COM port and both expect the COM ports to talk to each other. So you see this in the G-code community, if you like, the C machining and computer manufacturing community. There's the amateur radio, one or two items in model railways that are where you're expecting a COM output and a COM input. And if they have to just talk to each other, this is a cheap and cheerful way of doing it. Any questions?